Welcome to our webinar on remote monitoring and control systems. We've been assisting with remote monitoring application implementations across the world for over 18 years. Remote monitoring systems vary and range from simple systems that track temperature and pressure to advanced systems that use algorithms that predict failures. Remote monitoring is done through cellular networks, Wi-Fi, and Ethernet connections depending on the location. We've designed this session to take you from a basic understanding to practical implementation and enterprise-level integration. Today, we will go over remote monitoring equipment and software, how to connect devices out in the field from anywhere, securely and reliably, along with how to integrate remote data with the SCADA system. I'm Maria Santella, our sales manager at ICP DAS USA, and bring 15 years of experience in the industrial automation industry with a strong focus on specifying equipment for control and monitoring systems, sales engineering, sales management, digital marketing, and project management. I have a degree in computer science, lead our sales engineering operations across North and South America, head our web development team, and play a key role in integration and strategic direction of our digital marketing initiatives. In today's session, we will be introducing remote monitoring and control systems, going over the sending of email and SMS alerts and remote HMI access. We will explore PLC remote control, which allows for implementing changes like the starting or stopping of a process or updating programs or parameters without having to go out to remote sites. OPC server for Open Platform Communications is a standard used in industrial automation that connects to hardware devices for data collection for easy communication between different systems. We will go over remote monitoring and control applications, and then Robert Morale, our engineering manager, will give a live remote monitoring demonstration. Robert has a degree in electrical engineering and leads our technical support team. He also teaches in our training classes and implements SCADA remote monitoring and programming projects. Real-time visibility into temperature, power, and environment ensures safety and uptime. Remote monitoring and control systems allow for gathering measurement data from the field like temperature, pressure, flow, tank level, and machine status. They send alerts when conditions are outside desirable conditions and allow for implementation of control actions like the starting and stopping of equipment, adjusting set points, and logging alarm data. Remote monitoring is widely used in the manufacturing, energy, water treatment, building automation, and oil and gas industries for improving efficiency and operations. ICP DAS USA provides remote monitoring and control equipment, including analog and digital I/O, PLCs, programmable controllers, HMIs, Ethernet and fiber switches, wireless technology, protocol gateways, signal conditioners, power supplies, and SCADA software. ICP DAS was established in 1993 in Taiwan. ICP DAS USA was launched in 2001 and supports the North and South American markets. We have a large R&D team with over 100 engineers that we work closely with to support our customers. We have a knowledgeable team and are committed to providing excellent fast service. We provide application consultation and specify products for your applications. Orders typically ship within about 7 to 10 days from Houston, Texas. Free technical support is provided with our solutions. Our manufacturing is ISO 9001 certified, ensuring we meet the highest quality standards for industrial applications. We provide a 1-year warranty. Most of our equipment has fire retardant plastic or metal housings. Our equipment operates in very high or very low temperatures and are low DC voltage and low power consumption. Free Easy Data Logger software for data logging, control, and monitoring from a Windows computer comes with most of our data acquisition equipment. ROAS compliance ensures our equipment's safe for people and the environment. We're a Windows embedded partner, and we provide many programmable controllers with Windows operating systems, including WinCE and Windows Embedded. Remote monitoring includes hardware and software that allows for viewing status and conditions of equipment at other locations. For example, engineers and production management teams monitor drilling parameters out at oil rigs including pressure and temperature from a web browser. They track production progress, control equipment, and view reports for analysis. Industrial remote monitoring allows for tracking status, performance, environmental conditions, and process parameters like temperature, humidity, flow rates, valve positions, energy consumption, and leak detection. Measurements on the screen often display as outlined in red or other colors when the values are outside of ideal conditions. Our analog input modules are widely used for measuring temperature, pressure, flow rate, tank level, and weight. Our analog output modules are being used to control valves, VFD motor speeds, and actuators. Our digital input modules are used for getting the status of equipment being on or off, push buttons, and monitoring pulse outputs. Our digital output modules are used to drive relays in unmanned aerial vehicles, drive alarms, trigger the shutoff of equipment, and more. Our PWM modules are used for fine-tuned motor control, and our high-speed counters are used for counting encoder pulses to determine the positions of machinery and robotics. Email and SMS alerting provides immediate awareness of critical events like when something fails, when a pump stops pumping, pressure exceeds set limits, or when power is lost. Status based on time intervals is convenient since you won't have to log in, but you can get a quick update. Alerts prevent downtime and notice proper personnel when they need to take immediate action. To send email alerts through AVEVA Edge SCADA software, there's a built-in email function, which is located under the project menu in the SCADA software. There you enter in your SMTP port, your username and password for your email address, and then you configure rules for sending the emails out. You can send SMS text message alerts through the email to SMS gateway by sending the email to the phone number in the email format which specifies the cell phone carrier of the phone you'll be sending the alerts to. Today's industrial landscape is fast-paced, and it's necessary to monitor and control field equipment. Raw sensors speak millivolts and milliamps. Our M7017Z takes those raw electrical signals and converts them into a standardized language, Modbus RTU. By translating raw sensor 4 to 20 milliamp data to Modbus RTU, M7017Z allows Essential Systems to see water tank levels at water treatment plants, which allow for making intelligent, data-driven, automated decisions. When the tank level is over the maximum limit, SMS text message alerts get sent out and the water pumps are shut off. M7017Z is an analog current and voltage input type Modbus RTU-based data acquisition module. Modbus RTU is a simple serial-based protocol in industrial automation that allows for reliable communication between PLCs, I/O, HMIs, and SCADA systems. It allows for communication up to 4,000 feet, which can be extended with a repeater like our I-7510. The communication travels over 2 insulated copper wires. Our M7000 series modules support operating temperatures between -25 Celsius to 75 Celsius or 13 degrees Fahrenheit to 167 degrees Fahrenheit. They're available in RTD, thermistor, thermocouple, current, voltage, strain gauge, frequency, pulse, counter, digital, and relay I/O types. They mount on a DIN rail and can be piggyback mounted up to 3 high. This diagram gives an overview of remote monitoring technology and demonstrates how data from raw sensors becomes a graphical representation on a SCADA dashboard. The field process begins when field sensors sending 4 to 20 milliamp signals to M7017 over an RS485 serial connection using the Modbus RTU communication protocol. The PLC packages the serial data into Ethernet packets and acts as a gateway as it makes the information available across the local network via Modbus TCP IP protocol. AVEVA Edge SCADA software pulls data from the network and scales the raw numbers into meaningful information like reactor temperature and gallons for tank level. The data is displayed over a real-time visual dashboard for operations to ensure systems are operating as expected. The data is collected and logged at desired time intervals, like every minute, and reports are generated that include the date, time, and the measurement of the tank level and reactor temperature. Minimum and maximum levels are established, and a warning log is included in the daily report. AVEVA Edge report templates are made by right-clicking the Reports folder in the Project Explorer and then naming the report. AVEVA Edge reports can be saved in PDF, CSV, TXT, XML, HTML, or HTML5, and RTF. PDFs are great for formatting reports and for displaying alarms and historical information. CSV files are great for data analysis for importing into spreadsheets or databases. TXT are simple text files for data logging. HTML or HTML5 is used for displaying reports in web browsers. XML is used for structured data exchange with other systems. RTF is used for making formatted documents. SCADA tags are unique software-defined variables that map up to physical field instruments like sensors, I/O registers, or PLC registers. You enter text in the report template and then specify variables from your project in parentheses to display the actual values in your reports. Reports support if-then-else type logic for displaying values. Then you save your report and configuration files get saved in your config file in your project. You can make a button on your screen for generating the report by going to the Graphics tab at the top of the screen and clicking the button object. After you place it on your screen, you can add a caption that will be displayed on the button. Buttons for opening and emailing reports are frequently used in SCADA projects. AVEVA Edge SCADA software provides a strategic overview of industrial processes and transforms field data into dashboards, trend graphs, and insights for operational monitoring. The platform functions as a watchdog and a historical archive. The alarm management engine tracks, logs, and sends email or SMS message alerts so no critical events go unnoticed. The data logging and historian captures and timestamps every sensor event, creating secure records for regulatory compliance and performance analysis. Connection to equipment is done through drivers, as there's an extensive driver library, and you can also create your own drivers. Built-in drivers like Modbus TCP allow for streamlined communication with field devices, and our ICP-DAS Modbus TCP-based Ethernet I/O modules. Remote monitoring systems are very scalable and easily integrate with cloud and other systems. AVEVA Edge supports SSL TLS 256-bit encryption on transit data, secure authentication, and firewall compatibility. Different users can have different levels of access and permissions, along with secure authentication and access. It allows for secure mobile and web page-based access for safe remote monitoring. It's strongly advised you place control system networks behind firewalls to isolate them from business networks. Regular updates are released for security. This infographic illustrates the primary differences between SCADA and HMI systems. You can see in a factory there's a conveyor belt making I/O modules and a touchscreen PLC, the touchpad HMI over here, is connected to different I/O modules for providing information like temperature and humidity. There's also power meters that are displaying the energy consumption, and operators can interact with the machinery and the robotics for starting and stopping the processes. So the PLC works as the brain of the system, and it manages the real-time logic operations. So you can implement logic. If there was 20 items counted going across this conveyor belt, then stop, because maybe after 20 items, the operator, the worker in the factory may need to take those items and bundle them up and put them into one of those boxes. So our VPD series and TPD series touchscreen controllers communicate over Modbus RTU and Modbus TCP. They come in different screen sizes, including 2.8, 3.5, 4.3, and 7-inch screens. They come with free HMI Works development environment that allows you to make graphical user interfaces and implement programming logic in C language and ladder logic. It has an easy drag and drop point and click type interface. There are demo programs for implementing most functions like reading and writing to Modbus registers, reading and writing to memory, timing operations, and implementing control logic. Tutorial videos come with purchase. The VPD series are IP65 panel mount, and the TPDs have optional enclosure boxes for wall mount, or they can be mounted in electrical wall mount outlets. The infographic here illustrates the primary differences between SCADA and HMI systems across 4 operational categories. You can see here on the left, there's an HMI, and it's displaying the tank status. So the water's getting processed in the tank by a pump, and the HMI has its own IP address. It's communicable over Modbus TCP, and the screen is refreshing at 1-second intervals. It's connected to a PLC, which is also connected to M7017 over RS485, which has level sensors connected to it. HMIs bring a lot of life to a control system. They bring real-time visualization. The HMI acts as the front-end visual interface and converts raw data from the PLC and data acquisition equipment into intuitive graphical gauges, charts, and text readouts for clear access to measurements, process levels, and temperatures. Logical operator control empowers on-site personnel to interact directly with processes by allowing for the adjustment of set points, start or stop of operations, and acknowledging alarms locally. Local HMIs can act as protocol conversion, and they can also operate as a Modbus TCP client. The HMI actively polls the PLC's IP address to ensure it's always displaying the sensors, the latest sensor readings and system status bits. These are purpose-built, ruggedized touchscreens designed specifically for direct mounting into control panels within harsh, high-interference industrial environments. The local HMI-based monitoring system allows operators who need immediate on-site control and applications that don't need the complexity of a centralized management server. At the field level, sensors provide that critical 4 to 20 milliamp signal, and the M7017 Modbus RTU based analog input module digitizes those signals into Modbus RTU communication, and it puts the data into Modbus registers for easy access from other equipment. The PLC implements the logic, manages the machine's operations, and communicates over RS485. Instead of pushing data across the entire plant network to a SCADA server, in local HMI systems, the PLC connects directly to the HMI via local Ethernet or serial link for instant visualization. Moving into remote HMI access, we transition from local on-site control to a world of total connectivity in today's fast-paced environment. The control room is wherever you are, whether it's at home or traveling between facilities. This shift provides reduced downtime through instant troubleshooting and significant operations cost reductions by allowing a single engineer to support multiple sites remotely. Beyond simple convenience, remote access creates a safer and more proactive work environment. Operators can track production and receive instant alerts to intervene before problems escalate, all while monitoring hazardous zones from a safe distance. Additionally, it streamlines maintenance, allows for firmware and screen updates to be deployed without the need for physical site visits. Technically, this is achieved through several standards, including VNC for screen sharing, integrated web servers for browser-based viewing, VPNs for secure data tunneling. And while these tools offer incredible flexibility, security remains the top priority. Implementing industrial-grade protections like two-factor authentication and strict user access ensures your remote visibility remains both powerful and private. Now that we've seen the differences between SCADA and local HMIs, it's important to note that remote access usually bridges the gap between them. By enabling remote connectivity, your local HMI gains the anywhere visibility of a SCADA system. You get minimum downtime through instant remote diagnosis and increased safety by keeping your team out of hazardous zones. Unfortunately, It's about having real-time data available when you need it, ensuring that whether you're across the plant or across the country, you have total required access and control. Expanding beyond simple remote viewing, PLC remote control represents a transition from the visual interface directly into the brain of the operation. This shift allows engineers to move from a passive observer to an active intervener, enabling them to change how a system behaves from any distance. By gaining the ability to analyze underlying code and I/O status instantly, teams can achieve faster diagnostics and deep dive troubleshooting that reduces recovery times from hours to minutes. This level of access translates into significant operational cost savings by eliminating travel expenses and allowing a single engineering team to support multiple plants simultaneously. Remote control facilitates real-time optimization and improves safety, as operators can fine-tune processes and adjust set points in hazardous or heat zones from a secure remote location. This ensures plants run at peak efficiency without physically exposing personnel to dangerous environments. The ability to perform remote code updates ensures that systems remain current and secure, allowing for the deployment of logic patches and firmware upgrades over the network without the need for manual on-site work or physical cabinet access. By moving beyond simple monitoring into the realm of PLC remote control, we shift from just seeing the data to actively managing the brain of the operation. This transition doesn't just offer convenience, it fundamentally changes the business impact of your facility by allowing for a more proactive and cost-effective management strategy. The business advantages of this remote access are clear. Through instant diagnostics, engineers can provide real-time code and I/O status. They can reduce system recovery time when failures occur. This directly leads to cost containment, as companies can eliminate regional travel expenses by supporting multiple sites with existing staff. This kind of system enables process optimization, so managers can fine-tune logic and adjust set points on the fly. This prioritizes personnel safety by facilitating the control of hazardous or high-risk zones from a secure remote location. With remote deployment, technical teams can securely push firmware patches and logic updates without having to go on site. VCEP software for remote control of WinPack and XPack programmable controllers allows for remote desktop access to manage and control from anywhere. The VCEP server runs on the controller out in the field, and the client runs on a desktop PC. And this software is free with our WinPack and XPack controllers. And those come with Windows operating systems like Windows CE or Windows Embedded. If your site doesn't have a wired connection, GTP 541M cellular gateway provides 4G LTE cellular communication and real-time data streaming and centralized fleet monitoring from anywhere. It sends proactive alerts straight to your phone, and it gives you the ability to perform safe remote configurations on equipment in hard-to-reach areas. It supports everything from VPNs to M2M cloud integrations with encryption. It ensures your remote sites are just as accessible as local ones. So this is like a high-powered industrial messenger. It eliminates the need to go out for site visits as alerts are pushed to your system. It has I/O on board. You get a data plan from a cellular provider. So this device enables you for internet access. And it also has digital I/O on board. OPC is like the universal translator for the industrial world. Here's how it works. Your ICP-DAS hardware collects raw data. It sends to an OPC server. The server translates the signals to a standard format that any OPC client, like your SCADA software, can understand. By using this universal translator, you're not locked into one brand, and you can pass information from the field to the front office seamlessly, ensuring your entire fleet is working in harmony. The OPC architecture functions through a structured three-layer flow designed to ensure total interoperability across an industrial network. At the top is the data source. It's the field level, which consists of diverse hardware like PLCs, sensor networks, and smart IIoT devices. Because these units often communicate in different proprietary languages like Modbus, Profinet, or Ethernet IP, they essentially speak different dialects that normally wouldn't be communicating with each other easily. OPC server solves this. It's the translation level, and it acts as the heart of the system. It functions as a unified data broker by collecting those various proprietary protocols and translates them into a single standardized format, such as the modern OPC UA standard. This middle layer is critical because it eliminates the language barrier between brands, ensuring that a sensor from one manufacturer can be understood by a controller from another. The final stage involves client applications, that's the user level, which subscribe to this newly translated data stream. High-level systems, including SCADA software like AVEVA Edge, historian databases, and cloud analytics, can then visualize and manage the information seamlessly. Because the data has been standardized by the server, these applications are no longer require specialized proprietary drivers, allowing for a scalable and secure flow of information from the factory floor to the front office. So to put everything in perspective, let's take a look at this cold storage facility application. In this environment, a single degree of temperature can change, and it can result in thousands of dollars in lost inventory. On the left, you can see our local sensors and HMI. This is the tactical side where the operator checks the refrigerant pressure. On the right, you see the strategic side. Thanks to remote access and cellular connectivity, a manager can be at home and receive an instant alert on their phone if a freezer door is left open. This system doesn't just monitor, it provides enhanced food safety and energy optimization by giving you a 24/7 window into your facility from anywhere in the world. To see the full power of industrial remote access, let's scale up from a single room to an entire university campus. This architecture here shows how we can take dozens of remote buildings and tie them into one centralized control center using a secure 4G LTE network. In Zone 1, we're monitoring solar power and water levels. In Zone 2, we're monitoring security through license plate recognition and gate access. In Zone 3, we're controlling campus streetlights and IT server health. By using the GTM cellular modules as the bridge, we eliminate massive costs of trenching fiber optic cables across the campus. Instead, every sensor and controller talks back to the master station over the air, giving you total smart campus solution that's very scalable and highly secure. This summary slide integrates every concept we've explored, illustrating the complete journey from data to the remote field to centralized management. It begins the foundation using essentials like hardware, pack controllers, I/O modules, and the GTP 541M gateway to capture raw intelligence such as temperature, pressure, and GPS location. This data is then protected by a secure bridge of VPNs and multi-factor authentication, ensuring that all remote programming and diagnostics remain encrypted and safe from external threats. To ensure all these systems communicate, OPC data solutions act as the universal translator, converting various proprietary protocols into a standardized format. This allows field data to flow seamlessly into SCADA systems or high-level enterprise ERP software for deep analysis. Ultimately, this ecosystem enables proactive management, giving you the power to send operational commands to distant facilities, whether it's adjusting a cold storage step point in agricultural storage or managing a university campus from any location. Now, Robert Morale will be giving a live demonstration on remote monitoring and control systems.
Okay, so for today's demonstration, I'll go over some concepts that we went over in this presentation. We're going to build upon this diagram right here that hopefully you can see. So basically there was a remote data acquisition module here, which brought in the values from the sensor. It communicates the signal via Modbus RTU over RS-45 to the PLC, which is doing the ultimate local control. Now, using Modbus TCP to connect to this PLC, you can read data from the sensor level and control level, and you can also, you know, interact with the PLC, maybe for supervisory control, maybe for data logging, or for remote monitoring. The key to this is this connection right here, which is done over Modbus TCP. In this diagram, the PLC communicates as a Modbus TCP server or slave, and the industrial PC could be anywhere within the plant, local, or in outer space almost, connected just by Ethernet through a system of standard networking, like through routers or switches. And the PC will be running the AVEVA Edge SCADA software, which I'll go over and show you some of the features shown in the diagrams of this presentation, showing you how to read and monitor data, how to trigger alarms, how to show some trend curves, and so on and so forth. The key to this diagram is using Modbus TCP. AVEVA Edge or industrial PCs can also use other protocols, but Modbus TCP is one of my favorite ones, and it's something that AVEVA Edge communicates very easily. There's a bunch of other protocols that AVEVA Edge can support, like Ethernet IP, OPC, like Maria mentioned, or even like Modbus RT if you wanted to go the slow approach. But Modbus TCP allows you to communicate locally through an existing Ethernet network or a private network. It allows you to do port forwarding through the internet to share data to other facilities, to other areas, and you can also communicate to cellular modules using Modbus TCP as well through proper networking. Let's see, let me go to the next presentation. Okay, so, this is just a picture showing how a system would work remotely. So this is the manufacturing plant where everything's happening. There's a local control, and everything's done through Modbus RTU. Data is shared from the process through Modbus TCP to various locations through Ethernet switches and routers. Assuming that there's a public IP address here or some way to remotely connect to this router, somebody from a remote office can go through the internet or through the local network, there we go, using just standard Modbus TCP through port 502. In this example, port forwarding is done from the public IP address to the local IP address so that you can connect to the local PLC and control and monitor the plant, and maybe trigger alarms from the remote sites or notifications if necessary. Okay, let's see. Let's go to the AVEVA side. Okay, previously I created this project where it pretty much just showed how to connect to a Modbus TCP device. That is the ultimate key to all this communication, whether it be local or remote. The key right here really is when you connect to the Modbus TCP device and create your tags, whether this IP address is a local IP address or the public IP address. So if you have a local machine and everything is connected by Modbus TCP locally, you'll likely have a 192 local IP address. If you have a remote site where you're connecting to, it'd be a public IP address or something that would be forwarded through from your router side, and then port forwarded on the other end to the actual piece of equipment. But the main idea is right here, this IP address and proper networking are what connect a local device or a remote device to AVEVA Edge. Now, there are other protocols. There's a whole list of drivers that AVEVA Edge has. Oops, let me just go add, remove, and they're all just shown here. There's Allen Bradley, Ethernet IP. There's Advantech, Siemens PLCs, BACnet, Bosch, but you can see there's a whole list of drivers here. We're going to be using the Modbus TCP driver for this demonstration. Let me go back to the screen. So previously I created this screen. Basically, it just maps some digital inputs, digital outputs, and analog inputs, analog outputs. For this demo, I have the analog output directly connected to the analog input. If you would like, to see how to do this, we can show you how, or I can link to the previous video where I went over this. But for this example, since we're limited on time, I wanted to skip the connection and go on to show you additional features like how to create alarms, how to do some animation, and how to do some trend curves. Okay, so AVEVA Edge software looks like this. This is the AVEVA Edge development environment. Basically, you can go to the main tab right here, create some screens. Right now, I just have one screen here, and then I have a second screen where it's just a template, or I think it's empty. Actually, I did have some information here, but let me just delete this so I can redo it for this demonstration purpose. Okay, so we have a blank canvas there, and we'll go back to here. So from here, what I like to do is let me just run it and show you what it does. Okay, so I click on the run and the runtime development. Oh, darn it. My bad. I need to go back. I actually didn't set this as startup screen. Okay, so right here, set as startup. Let me stop it and let me start it. Of course, this happens live, but we'll figure it out. Okay, so let's do this. Let's go set as startup. Again, let's do, maybe I need to stop it first. That might be the key. Whether this works or not, we'll move on, but come on. Aw. Oh well, we'll move on. Let's see. But basically, what we want to do here is just show you that this analog slider controls analog input. We'll move on and we'll show you how to combine this. But when you want to add a second screen, you just go over here, right click on screen, and do insert, and it'll show screen attributes where you can just name it. I don't know. I'll call it alarm page. Actually, let's just call it alarm. I don't know if it'll have a problem with the space. Okay, so basically there would be a screen 3, which would be called your alarm screen. So what I want to do is go back over here and let's see, let me first of all show you how to just create an alarm condition. So the alarm condition is done here under tasks. Basically come over here to alarm, right click and click insert, and it will create an alarm window like this. Just double click here, you can name it, and you create your alarms here based on the tag and the limit which you want to trigger the alarm. Like for instance, for me, I have an analog output. Let me go AI, was it 0 or 1? I forget. I think it was AI 0. And we'll say if it's over, it was 4,000 to 20,000 because it's 420 milliamps. So let's do if it's over 1,800. And let's create a second one where AI 0, let's do a low limit alarm, is maybe at 5,000. Let's see, we'll allow here. And we'll just say maybe tank level is too high. Tank level low. Okay, we'll just put some messages that we want to do. If we want to trigger email alarms, we could also do that here. Basically, you just go to email settings and you just enable the sending of the alarm. And I'll show you also where you set the mail server and stuff. That's actually done over here under, I think it was project. Yeah, project. And then you go email server, or I'm sorry, email settings, and you put your outgoing email server settings here, your password, and so on and so forth. Basically, just fill it all all out. And if you do use POP3, be sure to check this little box and then click OK. There may be some email problems because of email security nowadays, but I know for sure that Google email now works, and I believe Hotmail/Outlook also works. So if you do need to use those public email services, they are supported. If you have problems, we can help you with that. With the AVEVA Edge, you do get a 40-hour test and evaluation, so you can download the software, install it, and create a project and run your project. So, please feel free to download it after the fact. Now that I've created the alarm conditions, what I want to do now is go back to the graphics screen. Actually, let's go to screen 2. That's where I planned on doing it. And all we do is create an alarm window, and you just click alarm and draw the alarm window. It'll show up here. It's all, everything's default right now. But if you want to adjust the properties, you just right click and, you can modify it all you want. But for now, I just want to simply display the messages. And also one thing we need to do is go back here, go back to draw, and we need to add some buttons so we can navigate between pages. So for this, let's see, we right click and we go to properties. And for the text, we want to call it alarm page. That's just going to be shown here on the button itself, so you know what you're clicking on. And then you click on command, and we want to just open the screen, and we want to select the screen, which will be screen 2. And we click close to do that. And then on screen 2, we want to do something similar where we create a button so we can get back to the main screen. I've forgotten this before, so that's why I more so remember. But again, you just right click, or I'm sorry, double click, that's what I did, and then just put home, adjust the command so that we can go to open screen and we could. I'm hearing background noise. Can somebody mute their... let me see. Somebody, I hear background noise.
I'll work on it, Robert. Don't worry about it.
Okay, sure. Okay, so basically, again, this button will go to home. So let's just try it now and see if it works. Let's go here. What did I do? All right, we'll go back here. It must be the other screen that I created. It wasn't here. It was this one. Let's close all. Save alarms, yes. We'll do save all, stop. Now let's try running. There we go. Okay, so again, we can create, or I'm sorry, modify the analog input through using this slider. I'll go to alarm page, and we see the tank level is too high. If we go back to here and get below 5,000, go back to alarm page, we should see tank level is low, and our messages show up. So we can go back and forth. Now what I'll do is I'll click exit, and let's add a trend curve so you can just see what's happening over a period of time. So again, we go back to our graphics tab. Let's put it on screen 2 since there's some space there. Actually, you know what? Let's put it on screen 1. I want to be able to control and have you see it. So let's go over here to trend. Just simply click on trend. I'm just going to draw it over here for now, and then we can move it to a different page later on. But for this, you just double click on it. Brings up the property windows. The only thing we really need to set here for now is the points. Later on, if you do need to do scaling or something like that, you can also do that here. But let's see, let's just call it tank level as label, and we'll choose our tag. Let's just do AI 0 like we've been doing. And we will click OK. And let's save it. And we'll run. Okay, so we should start seeing the tank level. Oh, I didn't adjust the level or the value, so we need to get it on the screen. Let me go back and set that. Okay, so on the axes, we need to, where is it? Where'd it go? Please? Oh, my bad. I think it's 4,000 and 20,000. Go. Okay, now it should toggle between the two. So let's see if it works. Okay, there we go. You can see the curve started appearing here. And we just do this. If anyone has questions afterwards, we'll be sure to answer them. We have about, only 9 more minutes. Okay, let me quickly go over an animation, because that's one other thing I wanted to show you just because. So basically right now we could just cut this and put this on screen too, and it will appear over here with all the properties. We'll space it nicely, put a nice background picture. But going back here, let's go back to screen 1. Let's just go to the Draw tab. Let's find a picture. So we can click on, I think we can just click on symbols actually. Let's just pick a symbol or a graphic. Let's just pick this for now and then place it there. When I click on it, up here are the animations which are available. So for this one, we can resize it. So we click on resize with it highlighted. Oops, we click on it, then we double click on it to adjust the properties, and we see the resize option here. If we did not click resize previously, then it would not have shown up. So let's just again associate this with AI 0, and we'll associate the width as well with AI 0, and we'll just do 4,000 to 20,000 because I know those are the values which our analog input goes between. If we did scaling, we can, also scale it, but let's just do this quickly and verify it works. So basically, this picture should start off and be adjusted based on the analog input. Let's save it, and let's click Start. Let's go here. So the picture is that big. If we bring it all the way down, it should shrink to nothing. If we bring it all the way up, it maximizes it. We can, enlarge the picture if we want to. In the InduSoft and AVEVA demos, there's a nice animation with the flame, so you could see like how much energy is being produced. That would be an example of when you would use this. You can also use it to show movement. Let me go open this other project, which I like to show. Where'd it go? I think it's PC demo. Let's see if this one did not stop the previous one. I'm actually surprised it let me do this. Okay, it's having problems right now, but let's see. For going back to the animations, though, if anyone has any questions, I guess now would be a better time to answer questions because I show we only have 5 more minutes left. We can go over additional demos or answer any questions if you would like. Maria, let me pass it back to you so you can put our contact information on the screen. Okay, if anyone has questions, please feel free to type it in the chat box or the Q&A box, or we can unmute you and you can ask the question live. I do see in the chat box there was something. Is it a question? Okay. Oh, there was an echo in the voice. I apologize for that. I just saw that information now. I don't see any questions here, but does anyone have questions?
My name's John, and I have a quick question. Can you hear me?
Yes, John. Yes, John. I can hear you perfectly.
Yeah. My question is, I was wondering if you have any feel for what AVEVA's, what the future looks like for AVEVA Edge, and what AVEVA's interest is in continuing to develop it and maintain it, considering their other
platforms, software.
platforms they're pushing. And also, we use Edge a lot, and I was wondering if there's any way to get feature requests or suggestions back to them, either through you or to them.
Yeah, we are a partner of AVEVA. We've been pretty much with them since they were started off as Indusoft. I'm not sure if you know that, but Indusoft was a software package that was developed for Windows CE machines. We manufactured CE packs, or programmable automation controllers, that came with Indusoft pre-installed. So we've been a partner since almost the beginning. We do have a good relationship with AVEVA and the Indusoft people. So if you do have suggestions and everything, we'd be happy to pass it on. I do know that AVEVA Edge is the direction they're going to. Indusoft is technically discontinued. If you have an existing Indusoft development license, you can purchase runtime licenses for that, and they will honor that. And the
It's not
development license will still
discontinued.
work.
If it's not discontinued, you can still buy Indusoft in version 7.0, 8.0, for example. But
Oh, it's
the
not
latest
advised.
version is at AVEVA Edge.
Yeah, because they're based on versions of Windows as well. So if you have Windows 10 or 11, 8.1 I think was designed when Windows 7 was around. The 2020 version I think is the last one, but AVEVA Edge is essentially the rebranded version of Indusoft that's going to get continuous updates. So as time goes on, they're going to get new updates and new versions. And you can purchase runtime licenses for those, specifically Energy Generation. Did that answer your question, John?
Yep, thank you.
Okay, sure. Let's see. The cost, Lewis wants to know cost. I think I'll let you take care of that, Maria, after the fact. How to connect Modbus RTU modules to Python data acquisition. That's going to be another presentation, but if you wanted to connect Modbus RTU to AVEVA, that is possible. Let me go back. Am I able to share my screen again? Let me share my screen and just go back over here. So instead of, can you see my screen? Okay, so instead of using the Modbus TCP driver, you just add remove driver, and it's, let's see, what is it? Okay, so previously we used MOTCP right here. This is Modbus RTU over TCP, but for Modbus RTU we use MODBU, and it would be shown here. Just click OK, and when it appears over here, you right-click and do settings to set your COM port settings, and you treat it just like you would with the Modbus TCP. Okay. Hopefully that answered your question. What other question do we have?
Okay, then I'll answer the question about the cost of AVEVA Edge 500 tag. So the lowest development and runtime license comes with 1,500 tags, and right now that's going for $3,971. And then for the development environment, the lowest version amount of tags is 4,000, and that's going for 2,936. And then the runtime, let me get that. There's different kinds for different operating systems, but if you're talking about just the standard desktop one, the lowest number of tags is 150. That one's 778. Then 300 tags is 1,890, and then the 1,500 tags is $2,457. And then these licenses are all just a one-time purchase. There's no monthly fee or anything like that, which a lot of the competitor software charges.
And for low tag counts, we definitely recommend you download the trial. And sometimes you could even develop your project using the trial and just play with the software, get familiar with it, and we'd be happy to help you demo if you use our hardware.
And yes, you can use these on chillers and boilers.
Okay, let me switch it back to you, Maria, so that, or actually, why don't you just
And
pop
yes,
your
also
screen
air
back up?
handling units.
I saw something about a student license. They don't have a student license, but again, the free trial would be what you'd want to use. And with the free trial, just be sure you close the software completely. Otherwise, your 40 hours could expire without you even knowing, because it might be running in the background. Okay.
Yes, so it could work for 40 hours, and then say you only work for 1 hour. Yeah, make sure to close it so you can get the full 40, and then you can also install it on another computer and get another 40 hours like that.
This will not run on a Raspberry Pi. This is for a Windows environment and Linux as well. See any other questions? Okay, we went 1 minute over, but I think we did a good job. Thank you all for attending. We greatly appreciate that for your time. We will put this on YouTube, and if you have questions that you want to get answered about any of our products or anything we showed today, please feel free to contact us with the information shown on Maria's screen, and we'll let you go, but you all have a wonderful day.
And we'll be sending a follow-up email that includes information on what we discussed along with the video when it's available. Thank you.
Thank you.
And please contact us if
Thank
we
you,
can help
Modbus.
with anything. Thank you.